We now get a green line and the test pass label. If you look closer, you'll notice that the print statements we added aren't being printed. For those to be printed, you need to add a -s flag to the command like so. This gives us a good insight of when things are called and the order of operations of our fixtures. We'll add just one more test to mark this part complete. I want to evaluate if I hit the page a second time, I get the number 2 in the counter. We'll mark the test as async, and we will also need the create test client fixture we used in the previous test. First, we generate a response from the home page, which should set the counter's value to 1. That is because the database is being destroyed and created with each new pytest function that runs. Since we test that the counter value is set to 1 on the first run within the previous test, there's no need to check the value. Then we hit the page a second time, and this time we assert that the value is indeed 2, if everything is working correctly. Run the test to see the result. As you can see from the output, the database was created and destroyed twice. But now let's say we want to actually check if the value in the counter collection on the database is indeed 2. To do that, we need to interact with the models, which means we still need an app context. To do that, we need to interact with the models, which means we will need an app context. We'll do that with the following code. First, we need to import the current app module from Quart to be able to get the database connection. So on line 2, add the following. Then add the current test app fixture to the test second response function. Then let's add the code to read the counter value directly from the counter collection. First, we create an async context with the with Python keyword. Inside the block, we can now get the Quart current app context SQL connection object DBC. We can then build the query, execute it, get the first row, and then check that the count column's value is equal to 2. Save the file and run the tests. Looks good. However, we haven't updated our web app Docker instance yet, so let's go ahead and do that. On the terminal, type this tells Docker to build all the services on the Docker Compose YAML file. All the changes we've done to the Poetry packages will now be installed. The web Docker container should now be up and running, and you can visit localhost 5000 in your browser to see the whole application running. If you want to run the tests from the Docker Quart web container, you can do If you're using VS Code, I have added the settings to run tests from the application. Just look for the bottle icon and click on it. You will see that in the first run, it will detect the tests and add a testing tree. At this point, you can run all the tests by clicking the Run Tests double triangle or debug using the triangle with the gear. Debugging will respect any breakpoint you add, so the test will stop at that point and you can further introspect the stack. And with that, we have a working database-powered Quart application with testing. We can use this as a boilerplate for any project that uses Quart and Postgres. If you want to grab the updated boilerplate at any time, just visit this GitHub repo.